On August 5th, 2012, the Curiosity rover landed on Mars with the mission to collect potential chemical and mineral evidence of a past habitable life on the Big Red Planet. Just this past month, Curiosity rover sang itself happy birthday. I don't know why a robot is tugging so hard on my heartstrings, and we could get all into the philosophical part of all of that, but we're going to keep it strictly scientific and ask ourselves, if anybody was on Mars, would they be able to hear Curiosity singing happy birthday to itself? Because as we know, in the vacuum of space, there's no air for sound waves to travel. So what about on Mars? Let's get into it. I'm going to throw a few numbers at you here, so just bear with me. Mars' atmosphere is less than 7% dense as Earth, as well as it has 96% carbon dioxide in the atmosphere compared to our 0.04% here on Earth, as well as they have less than 1% of oxygen on the Big Red Planet compared to our 21%. With all that in mind, what that means is sound just doesn't travel that far. Now, although troublesome dust storms can happen some places on Earth, they are a very regular occurrence on the Big Red Planet. And not only are sand particles so small, they're actually electrostatic, so they stick to your body and your hair much the way foam packing peanuts do here on Earth. So, yikes. Okay, but back to what we were talking about. The thin atmosphere is not a conducive conduit for sound waves to travel very far. In fact, hypothetically, some sounds such as hoofbeats would travel further through the ground through reverberation than through the air. Yeah, one of the first sounds ever analyzed from Mars came from the Perseverance rover, its microphone specifically. It had been studying rock and soil samples since February 2021 in order to determine if there had ever been past life on Mars. When Perseverance fired lasers at these rocks in order to study them, it created audible sound waves, and it allowed scientists to measure how sound waves are carried on the Martian planet. Specifically, it allowed scientists to study the speed of sound on Mars, which allowed us to understand what sound sounds like on Mars. Apparently what we've learned is that lower pitch sounds travel slower than higher pitch sounds, but higher pitch sounds do not travel as far as lower pitch sounds. And there is a NASA website, which of course I will link so that you guys can check it out, that not only can you check out different sounds, like city sounds, like birds, trucks backing up, just different random things, like what they would sound like on Earth in comparison to what they sound like on Mars, but you can actually record your voice and you will be able to hear what you sound like on Mars. Just pretend that you have really good hearing and someone is standing 200 feet away and they're trying to tell you something and it's just struggling to carry. That is kind of like what it sounds like on Mars. It's like a muffled version of everything, and the higher pitched your voice is, the less it's going to travel. But the higher frequencies travel faster, the lower frequencies travel slower, but they travel further. So let's try a few out. But wait, there's more. Hello, my name is Brittany. Please follow me for more awesome information about space. On Mars. Hello, my name is Brittany. Please follow me for more awesome information about space.